Welcome to Across the Globe. Today we will learn about working with JSON in Go. JSON, JavaScript Object Notation, is a lightweight data format commonly used in web applications for data interchange. Go programming language offers native capabilities for both encoding and decoding JSON data through its Encoding JSON package. This feature allows developers to seamlessly convert Go data structures into JSON format and vice versa, enabling straightforward interaction with external systems or services that utilize JSON. As a result, developers can efficiently work with JSON data in Go applications without the need for third-party libraries or additional dependencies. This built-in functionality simplifies tasks such as sending HTTP requests or handling API responses that involve JSON payloads, streamlining development processes and enhancing interoperability in Go-based projects. To convert a Go data structure into JSON format, employ the json.Marshal function. An instance in Python involves importing the JSON library, defining a data structure like a dictionary with key-value pairs, using json.dumps to convert the data into a JSON string, and then printing the JSON data. Decoding a JSON string into a Go data structure can be done using the json.Unmarshal function. For example, in Python, you can achieve this by importing the JSON module, creating a JSON string, and then using json.loads to decode it into a Python data structure. Similarly, in Go, you can do this by using the json.Unmarshal function to decode a JSON string into a Go data structure. This function takes the JSON data as an input byte slice and a pointer to the Go data structure you want to decode it into. For instance, if you have a JSON string like name John, age 30, you can decode it into a Go data structure in the following way. Go type person struct, name string age int, func main, JSON start name John, age 30, var person error json.Unmarshal byte JSON stir in person. If error equals nil, fm.println error decoding JSON error, return fm.println person.name person.age. In this example, the JSON string is decoded into a person struct containing name and age fields. The json.Unmarshal function populates the person variable with the decoded data. To define custom JSON data structures in Go, you can utilize struct tags. These tags are added as metadata to the struct fields and allow you to specify how the struct fields should be represented in the JSON output. In the provided example, a struct named person is defined with two fields, name and age. The JSON tag is used to specify the JSON key associated with each field. This way, the name field will be represented as name in the JSON output, and the age field will be represented as age. For instance, if you create an instance of the person struct with name set to John and age set to 30, and then marshal this struct into JSON using json.Marshal, the resulting JSON output will be name, John, age, 30. By using struct tags in Go, you can easily customize the JSON representation of your data structures, making it convenient to work with JSON APIs or data exchange formats. When working with JSON data in Go, ensuring error checking is crucial to handle issues during encoding or decoding operations. Neglecting error handling can lead to unexpected behavior or application crashes. In the provided example, the JSON data contains a mismatch between the expected data type and the actual value, age, as a string instead of an integer. When attempting to decode this JSON data using json.Unmarshal, an error will occur. The error must be captured and handled appropriately to prevent any adverse effects on the program's execution. Always pay close attention to potential errors during JSON handling to maintain the reliability and robustness of your Go applications. Working with JSON in Go is like translating a foreign language conversation into your native language. Just like how you need to understand the structure and syntax of the foreign language in order to accurately translate it, in Go, you need to understand the structure and syntax of JSON in order to work with it effectively. If you miss a key component or mistranslate a word, the message can be misinterpreted or lost. Similarly, if you miss a key element in the JSON structure or misinterpret the data, your program may not function as intended. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Code snippet provided is a Go program that demonstrates how to work with JSON data. It starts by defining a book struct with fields representing book attributes like title, author, pages, and year. The main function opens a JSON file named books.json, decodes the JSON data into a slice of book structs using the JSON package, and then iterates over each book to print its details in a structured format. By utilizing the JSON package in Go, the program ensures proper data decoding and error handling when working with JSON files. This allows for easy access to specific fields within the JSON data, enabling developers to interact with and utilize the information as needed. This code example showcases the importance of understanding JSON structures and how to effectively leverage Go's capabilities to parse and work with JSON data. It demonstrates a practical approach to handling JSON data in Go, making it easier to process and utilize information stored in JSON format efficiently. One real-world application of working with JSON in Go is in web development, where JSON is commonly used for data exchange between servers and clients. For example, a web server written in Go may receive JSON data in an HTTP request, parse it using Go's JSON encoding and decoding capabilities, and then process and respond to the client accordingly. Another industrial application is in microservices architecture, where JSON is often employed as the standard data format for communication between microservices. Go's ability to easily handle JSON data makes it a popular choice for building microservices that communicate with each other via JSON payloads. Working with JSON in Go allows developers to seamlessly integrate their applications with other systems and services that use JSON as the data interchange format, enabling robust communication and interoperability across the globe. Keep learning, stay curious, and I'll catch you in the next video.